Now, let's move on to something called conservation of mass. And won't be long here because what we were doing previously, those numbers that we placed in were
makes
actually,
it fairly obvious.
Yes, telling us that we are conserving the mass. We started with so much, we still have to get out with so much.
And the idea of an equation, just like in mathematics, what you have on the left side of the equal sign, or arrow in this case, you've got on the right. So amount of mass you've got on the left, you must end up with that same amount of mass.
Exactly.
Okay.
So here, what we are saying is the mass of substances involved in a chemical change remains constant. So what you start with, you end up with.
We don't lose any mass.
We don't lose any mass in terms of mass there. And or alternatively, we can say the same thing in terms of atoms. We say atoms of each substance involved in a chemical change are conserved.
Okay, that's an interesting point here, because what you're also saying is that in chemical reactions, the number of, if you've got an atom of sodium, after the chemical reaction, that atom of sodium is still there.
It's still there.
You may have taken an electron away,
it has been
make it
rearranged,
ion,
but it is still there.
It's still sodium.
It's still sodium atom. That's what it means. So that's very important for you to understand, because these rules, the conservation rules, energy, mass, charge, you have to know them and understand them, because that's what we're saying, that the universe is actually intact. We're not removing anything or bringing anything into it, and all this is actually explained within the rules of conservation of energy, charge, mass.
It's just occurred to me, when we're talking about ions, you've got a sodium and it loses an electron. But that electron goes somewhere else. It may be added to the chlorine, for instance. And so that you've got an Na plus, and then the chlorines become negative, and that's why these two things join together. But the total amount of mass, total number of electrons, total number of protons, total number of neutrons, total number of atoms, they're all still there.
All there.
Okay.
None is lost. Right. Conservation of energy, I've just spoken about it.
This is the big one.
Yeah.
This is
now,
the big one.
Energy is never created nor destroyed. And in chemical reactions, where new substances are formed, energy is released during the formation of bonds. So when those bonds form, energy is released. When the sodium chloride bond is formed, energy is released.
And we'll feel that as heat,
we will
presumably.
feel that as heat. Now, either that bonds are formed or bonds are decomposed, broken up.
Right.
So when that breaking up of bonds happens, energy is needed to do that.
Okay.
So like in the water molecule, H2O, we needed energy to break the bond between hydrogen and oxygen, so that when we start with H2O, we end up with hydrogen gas and oxygen gas.
So if we've got two things and they form a bond and energy is released,
yes,
if we want to break those apart again, we'd better get that amount of energy back here to help us to break it apart.
Exactly.
And it's equal, because whatever energy was lost to the system when this bond was formed, it's lost, it's not destroyed.
It's not destroyed.
We need to get that amount back in order to separate them out again.
Exactly. So that is again very important for you to understand. We have spoken here about, just to summarize, chemical change versus physical change. We have also spoken about how do bonds form, in a way, because we're saying to you bonds are formed. When bonds are formed, energy is released, and when bonds are broken up, you need energy, exactly the same amount of energy that was released when the bond is formed,
to separate
them. And we also spoke to you about how you can predict, and we just sort of limited it to one thing. How can you predict chemical formulae formed when metals react with oxygen? And we're going to end it right there. We hope you enjoyed the lesson. We're going to sign off now. My name is Tinyiko Wamachabkosa.
And
Bye-bye.
Peter Glover saying farewell.
Yeah.
Summary: in this lesson you learned about physical versus chemical change, the conservation of mass and energy during chemical change, to understand microscopic interpretation of macroscopic changes, more about the formation of metal oxides.